reason is lower error metrics, or you could say lower residuals. Okay. Or do you want me to type them down? They come under error. MAP comes under error metrics, but there are other ones also that you have to consider. So RMSE is one thing used, and residuals basically how to say. How do you calculate your error metrics? By the residual value, right? The difference between the predicted and actual value. So those you could say residuals for that instance. Wait, let me type down. This should suffice. Is that good? Can we move ahead? We're looking for test sets for both, but here we are. Our concern is for prediction, so we are looking for test sets. Your question is right, but with respect to the data presented to us, the seasonality and trend are not that much accounted with ETS. It should work properly, but it is not accounting for it. So when it's not accounting for it, we'll use one that is making good predictions with simpler algorithms. That would be linear regression. So MAP is kind of linear metric, but when you talk in terms of residuals, as in the difference between the actual value and predicted value, then the residuals for TSLM are lower. So residuals or error metrics, you could use. That's why I just mentioned residual error metrics. So essentially, they both mean the same, but mentioning residuals is another. Talking about residuals alone is a different concept. You can always put them to see, of course. Plotting is for us to understand how they are changing, but to make a fair decision on in terms of metrics, this should be enough. And for the last question, if we optimize the smoothing parameters in the Holtz-Winter model, is it likely to get values closer to 0? Let's do that. Let's try with the values ZAA instead of triple Z, and look at the values and make predictions and get the accuracy. Do you think accuracy changed here? Accuracy metrics changed here. And go for M. So what is happening? When you are changing the accuracy, the metrics for the ETS model, it is understanding the training data very well. The RMSE scores are getting better. For example, here initially the RMSE score for this is 257. It is getting down to 145 and even getting down to 143, but it's performing bad on test data. So there is a chance, but it depends on what kind of metrics you are using. So at least for error metrics in terms of the training data, changing the values of the changing the hyperparameters, they might get the error metrics close to 0. Both have greater RMSE values. We can't say worst predictive models because when it comes to real data, your predictions won't be better. For example, if you are predicting stocks data, if you have accuracy of 8%, then you are doing a great job. Like 8 to 12%, if you have an accuracy of 8 to 12%, you are predicting your values accurately 8 to 12% of the times in real world data, then you're doing a great job when it comes to stocks. And when it comes to cryptos, 8% is you are on God mode, if I can say, like literal God mode. But when it comes to health data or safety checkups or what else? Yep, health wherever there's need for understanding things very space, astronomy. When you come to these things, if your prediction is 95 or 96, it's bad. You have to have 99, 99.9. So it depends on what you're predicting. You can't say worst predictive models because the values are higher and they're not predicting close enough to the real values. If the if the uncertainty is accounted for, then even 8 to 10% is a lot. You're supposed to automatically calculate the best option. Why do we have to try? If the z values are so initially when we started with the question, we are supposed to take ZAA. This is supposed to be ZAA because we see an additive trend and additive seasonality. But to give you a fair understanding, I started with Z double Z. So if you start with ZAA, your error metrics are this. Your MAP is worse. It's 7.07, and when you get when you change that to Z triple Z, your accuracy would be 4. I mean, it's getting better. That is what they wanted to ask. Does that make sense? Yeah. Now, I think I went slightly overboard with this question. Let's get to the last question. Take a couple of minutes, read this, and this will go pretty quick, I believe, because I think we reinforce the concepts of TSLM here. So this should go pretty quick. Take a couple of minutes, 17:14. We'll get back at 17:17. I'll be back in a while. In the meantime, just try to understand this, get the idea, and we'll discuss it. Give me a couple of minutes.
I have a quick question to the class then. Are we saying that the question 4, because questions 1, 2, and 3 were supposed to be based off ZAA, that if we optimize the smoothing parameters, which is using ZZZ, is it likely to get you values that are closer to 0? Why or why not? The answer is yes, due to a smaller MAPE score. Excellent. Look at me, I should be teaching the class. That's unbelievable. Thank you.
Question 4. Okay, for question 4, imagine we have started. So we are supposed to start with ZAA, where we are asking R to use zero error metrics based on its understanding, and we are saying that there is additive trend and additive seasonality. In that sense, we'll have the error metrics to be higher, as in the test MAP would be 7.8 or something. The fourth question was, what if you change the values of these hyperparameters? Would the values come closer to zero when we use the original ones? So if we use triple Z instead of ZAA, the values are actually coming down, right? The values for triple Z are 4.5 for test. MAP is 4.5 for test, but for ZAA, it's 7.8. So we could say the values are coming down for with a change in the hyperparameters, and if there's a possibility they might come down to zero. We could say that. Does that make sense? Yes, we still go with the linear regression model because it's easy to compute and it has better error metrics than when compared to the Holzwinter model. Great.
Sorry, a random question as well. Do you know when we'll be getting the homework results back? I know we've done 2, and this will be 3. Well, I guess it will be getting it all together at the end.
I'm not sure, Robert, because last year I was grading the homework, but that was happening weekly. This semester I wasn't assigned to the task yet. I'm not sure if I'll be assigned, so I'm not sure.
Thank you.
Yeah. Basically, we are supposed to start with ZAA because we are assumed to have clear understanding of our data, and the data says there's additive seasonality and additive trend. We are supposed to use ZAA. We are expected to use ZAA, and then we are expected to experiment a bit and then see if the values are going down with other hyperparameters. Does that make sense? Yeah, great. So now let's bump into the 17.6 question. And can someone give me a premise of this question, please? Just a basic premise of what is happening there and what are we expected to do. We have dealt with Sune data before, so just recollect things and try to understand, explain what we are supposed to do. Of course, the question is right there, but what is just give us a few bullet points on what I'm supposed to do, and we'll get started right on it. Any ideas?
Venu, can you repeat the answer for 18.6D?
Which one? Which one, actually?
Yeah, the 18.6C, fourth one.
Fourth one. So, with increase in parameter, with a change in the hyperparameters for the Holzwinter model, the values, the error metrics are likely to go to zero. That's enough. That should suffice. Is that good?
No. Can you explain that please again?
Okay. Wait. Let me put it in a different manner. So, imagine here for the first model where we have considered ZAA. Do you understand why we are using ZAA here?
Yes.
Because we have seen the plot to have additive seasonality and additive trend. So we are using the ZAA model. So what is happening is when we use this model, we get an accuracy score of 7.07 for MAPE value, right?
Yes.
So when you compare it with the original value of the TSLM model here, where is it exactly? Yeah, the TSLM model. The MAP for TSLM model is 4 and this is 7. So based on this judgment, which model would you consider to be working properly?
The second one.
The TSLM model, right?
Yes.
So the fourth question they presented for us is, what if you change these hyperparameters? Would there be any difference in the values of error metrics and would they come down to 0? That is a question presented to us. So what are we doing is, if our line of thought as the additive seasonality and additive trend is not working properly, then we are asking R to make decisions based on its information presented to it. So we are saying take your thought and use whatever is necessary and get the lower metrics. So when we put triple Z, that is happening. So when we put triple Z, the MAP metrics have gone down, right? Can you see this? The test metrics.
Yes.
So essentially, with the change in the hyperparameters of Holz-Winter model, there is a change in the error metrics and they're getting close to 0. Does that make sense?
Yes.
And if you still have doubt, we'll just hold back at this point of time. We'll solve the last question and we'll take it after the class. Is that good?
Yes, I got it.
Yeah, great. Thank you. And so with the 17.6 question, what are we supposed to do? How are we supposed to start the question? What are we supposed to do?
Load the data, plot the souvenir sales, and then plot time plots.
Mm-hmm. Right. One time plot with respect to the regular data and other time plot with respect to the log of sales. So is everyone clear with this concept? Because I believe we have gone through this in the last class. Yes. So can someone drop me the code instead of just pulling it down? So can someone put down the code for me and we could use it for the class? Is someone working on it, or should I start typing?
Can you repeat what we have to do here? Is because I didn't understand.
Where exactly? For the 17.6 question?
Yeah.
So the question presented to us is, so we have data of souvenir sales within the time 1995 to 2001, right? It is a monthly data. What they're asking us to do is, they presented us with two plots. The one plot is with respect to the regular the sales without making any adjustments, and the second plot they've taken log of sales to see if there is any exponential trend. So they're asking us to recreate those two plots and see if there are any differences with respect to the regular plot and the log data plot. Does that make sense?
Yeah, thank you.
Yeah, great. So can someone drop me the code? Yes, we have code here. Okay, let's use this. Uh, 17.6. Hashtag loading data. And we have got the data, right? Hashtag data exploration, and we have with here. Wait. Read.csv. And we have monthly data. Then we have creating a time series, and we did a time series. That's great, and we are looking at the data once we have it. That's great. And what next? We have, that's great. You have split the data into test and partition, but we'll come to that part in a while. Yes, we have to visualize the data first in two different plots. One plot with respect to the sales and other plot with respect to the log of sales. So let us take a little. Wait, you guys are going in the right direction, but you have missed a point here. What is that? Right. First, you haven't visualized the data and you didn't do the first task you've been given first. The first task is based on the two plots, what predictors should be included in the regression model and what is the total number of predictors in the model. So for you to understand what is there, you have to understand the components of the data. To understand the components of the data, you have to visualize first in two different aspects. So yes, we have answer from our peers. Yes, right. Plot with respect to the regular data and plot with respect to log of x and y. Thank you so much. We'll use that first. Hashtag. So this is okay. S dot sales. We have this data. S dot sales. Have this. So what do you make out of these two plots? What do you understand from this? Exponential trend, right? When you are using exponential trend. Yes, we get to see the exponential trend when we use the log of data. And to the second part of the question, how many predictors would be there in this particular model? If you create a model, how many predictors would be there? You can take log on x and y to see how it is there, or you can take only log on y. Anything. If you are having a clear understanding of data with respect to only y, just take y. But with respect to time, there wouldn't be a difference, much difference. So just put x and y, just y. It doesn't really change the scaling format. So yeah, second part of the question: how many predictors do we have here? This is an interesting question. This is a really interesting question. How many predictors do we have for this model if you are creating a time series plot? You definitely know once we create a plot, but without the plot, what do you think? How many elements do you think we would have? Any ideas? Just half an hour more, please. Just be active for half an hour and you'll be done with me.
I don't think it's you, Vinu. I just think people don't know. You mean
I know it's a.
Do you mean like is it a trend and seasonality? So does it have trend, seasonality, noise, and level?
Yes. I mean that. So how many components do we have?
So you have seasonality, you have trend, everything has noise, and you have level.
Okay, so we will hold on to that thought. We'll answer that question with the next question, all right? Because right in front of you without showing the answers, it will be difficult for you to comprehend. So we'll leave that hanging for a couple of minutes, and we'll skip to the question B. Run a regression model with sales as outcome variable with linear trend and monthly seasonality. Remember to fit only the training data. So for this, you have to split the data first and then create a time series plot. So whoever can provide me with the code, please do. I know you have provided the code earlier, but I want a code with the model. It is fairly simple. The model is fairly easy. It is the model with the trend and seasonality because we spot trend and seasonality there. So the model will be TSLM of the train.ts tilde trend plus seasonality. So it's a basic code. When I say predictors, that time series components, but there's a catch to it. We'll touch that in a minute. There's a catch to it. There's a little catch to it. Which section do we take log? It's answered. Be equal to the number of observations. No, it will not be equal to the number of observations. No. We're talking about the number of predictors. Predictors are different and number of observations are different.
I'm using a different computer. I can call out the code that I have for it, but someone else probably might be quicker pasting it in.
Sorry?
I can call out the code to you, but I have OR on a separate machine. I'm using my other laptop for the conference.
Okay.
I can't copy it.
Okay. No worries. In the meantime, let's get some code from the chat we have. Let's split the time series data. Train.ts.
Will I call it out to you whilst other people are still typing away, just to get us going?
Yeah, I'm just trying to copy here. Sorry, because there's no point in typing the code again and again.
Yeah, no, that's fair.
Because one issue I face is my apostrophes are broken. That key is broken. So when I have to do touch on that, I have to actually press hard. That is one of the reasons I ask you for code every other time when there's apostrophe included in the code. See, and let me start with the code. Hashtag splitting data. And we have sales here. Yes, sales. Yes. We have plotting it again, right? Wait, we don't have any.
I don't think we've
Yeah, I have an included invalid here. 12. And once you have invalid, and train x length of s dot
sales.
sales of ts minus invalid. We have that, we have this, we have this. Right. Gotcha. And now let us create a model, hashtag creating a model, and that is LM. What should we call sales.lm, and that should be TSLM of pain.ts. Yeah, that's what we define. Tilde trend plus season, and that gives us the model. And once we have the model, we explode the model. Control C and Control A. We explore the model, and another way to have a look at the model is summary of the model, summary of the sales.lm. Now, if you look at this, can you answer how many variables we have, or how many predictors we have here?
12.
You sure?
11. Oh no, 13. Trend is just season 1, isn't it?
Sorry?
Is trend just season 1?
Mm-hmm.
So then,
We have dummy variables for other seasons. We don't have season variable for one. The other seasons are dummy variables basically. So we have trend, we have the base intercept, and the other 11 variables. Does that make sense?
Can you repeat, please?
We have the intercept, and we have 12 of the predictors.
12 predictors.
Does that make sense? Is it all right? So when they ask you how many predictors we have, what will be your answer?
13.
And that would be?
Trend, season 2 to
Mhm.
12, and then you said the intercept as well.
All right. Next, hitting on the next question. Examine the estimated coefficients. Which month tends to have the highest average sales during the year, and why is the reason? How do you say which month has the highest sales here?
Season 12.
And that is?
32,469.
No, which season is it? Which month is it?
Oh, month, December.
December. And why might be the reason?
Holiday sales.
Right, exactly. Holiday season. Okay, so I have a couple of questions here. Okay, now they're showing only estimate values, standard errors, etc. If you're using just the model, you wouldn't get this. You have to use summary of the model. Once you use summary of the model, you all have this. Yeah, and going to the next part of the question, the estimated trend coefficient is 245.36, and how much did we get? 245.36, accurate. So what does this mean? What is the physical interpretation of this point? We've gone through this concept, just trying to reinforce it again. So what do you understand? What is the physical interpretation when we say trend value is 245.36? What do you understand from this?
That the trend for every t plus 1, y increases by 245 for trend. Then for every season, it's broken. So, and then for season 2,
it depends on the season, right? Exactly. Is everyone clear with that? Can everyone answer the question why? What does 245.36 mean when it comes to physical interpretation? So it means that sales go up by an average of 245.36 every month, where here our time period is every month. So every month the sales go up by $245.36. That is what the physical interpretation means. Is that good?
Yeah, I'm just talking it out.
Yeah, sure. Now let's move on to the next question. Here they are asking us to run a regression model with an exponential trend and multiply to seasonality. Remember that for the training data, that's another story. But how do we get exponential trend and multiply to seasonality? How do we do that? How do you get an exponential trend? Forget about seasonality.
Instead of using trend and season, we have to use trend and season square. I think that is.
Sorry, come again, please.
With the I think that is perhaps with the seasonality and the trend like a square, like I don't know. I think that is something like that.
We can use log here. Log will get down this to the exponential scale. Once we have that, we can use that for the data. Does that make sense? Here, when you look at the plot, this is a plot on a regular scale. This is a plot on a log scale. Log scale accentuates your exponential information. So if you use an exponential plot, then we are accounting for the exponential trend. And once we have that, we get the information out of it. All we have to do is, to answer this question, we have to use the log scale instead of your actual values. Does it make sense? Are you getting the point here? Yes, no. Repeat again.
Do it again, then. Do it.
Yes. So we have created a plot based on this scale, right? Here we use just the train.ts information. That is, we are using train information without any manipulations. When we do that, are we actually capturing the exponential trend here?
No. Well, we are. No.
So if we have to capture the exponential trend, all we have to do is convert this into the exponential trend data. That is, use a log of it to convert this into exponential form. And once you do that, you can use the same TSLM model on that to get the exponential information. Does that make sense? It will capture the trend better. And even look at your summary values. Only two, the trend, and only two of the variables are significant. So this is not even significant prediction. So here the exponential trend concept is not captured with using just the regular data. We have to use the log of data to capture the exponential trend. Is it clear? Even a little bit. Are you getting an idea about it? Not exactly perfect, but some idea regarding in the back of your head. Okay, this does make sense, kind of idea.
Yeah, it does make sense. Yeah.
Yeah. So all we have to do is create a new model based on this hashtag exponential model and use the same information, but we take the log of data, log of TS, and we call this 1, 1. Now, if you look at this, don't you think here, look at the significance levels. All variables are significant at this point of time. And why are the values in 0.2 and 0.28? Here, our values are in terms of dollars. Australian or Canadian, which dollars? Wait, that's a question. Australian dollars, right? Here we have information in terms of Australian dollars, but we have here 0.2, 0.02, 0.678. What does this mean? What do you make out of this particular model? Right, we have the percentages now. That's it. We have the log of values. So if we want to get the original values, what should we do? We have the log of values. If you have to get the original values, what should we do? Put anything in cap. It's like taking a step back. That's it. Take exponential again. Yes, right. Use exponential instead of log and you'll get the values. Does that make sense? You have used the log and you have to get rid of the log. All you have to do is use exponential. So now let us answer the other question. Fitting a model with log scale with linear trend is equivalent to fitting a model to scale with what type of trend? C1. I think you exponential. Exactly. We are trying to get the exponential trend out of it, and using log of sales, we are getting the exponential trend. So that answer is exponential trend. And the estimated trend coefficient is 0.2. What does this mean? This might be a bit tricky, but I believe you guys can answer this. We have 0.02.
That will increase 2% every month.
Yes, exactly. Right. It goes 2% every month. That's it. Thank you. And to the third question. Use this model to forecast the sales of February 2002. Who is going to come up with the answer? How do we forecast? What is the how do we forecast the value for February 2002, not 2001? Okay, let me rephrase the question. Put the values in the equation, right? Hamza, you're right, but yeah, so the 2% increases. Here we get information in terms of percentages. Initially, we had information in terms of dollars. With every month, there's an increase of $245 in average. That is for month. That is for regular data. But here we get everything in terms of percentages. So 0.02 is 2% essentially. So there is an increase of 2% in sales every month with respect to this data. That's it. 2% signifies for increase in the sales value every month. Is that all right? Yeah. Yeah, answer to the first question is exponential. And if we have to predict for next year data, how do we predict? How do we get the information? How do we make the predictions for next 1 year? Next 1 year, you are right, but we have to get only for next 1 year. How do we get for next 1 year? That is h equal to 12, right? Great. Let me go to the. Okay. Y threads, I didn't call Y threads before, and forecast of sales.lm1, and if for next 1 year it's 12, but they're asking us to predict for 2002 February. So what should be the value of H?
14.
14, right? No, it's 14 because we'll get, if we use 12, we get from 2001 January to 2001 December. But if you want to get for next February, we have to get from 2001 January to 2002 February. That is 14 months, right? So H, the value of H should be 14. And when we make it 14, we get the value of Y threads and sorry, I've put 1. And when we get the value of Y threads, it is 9.744. But how do we get this in terms of dollars? We have 9.744667 to be the value of percentage increase in sales with respect to February 2002. But how do we get that in dollars? You gave me the answer before. It was right there.
Yeah, you have to take out the exponential.
Take exponential. Thank you. But instead of just taking that argument, all of the values, take this. There you have $17,062.99. So this is the prediction for February. Does that make sense? Is that okay? Any questions till this point of time? Anyone? Is it good?
Yes.
Yes, great. So finally, the last question: which model would you prefer? The TSLM model, the regular model, or the model with log? Which model would you go for? And why?
For this kind of data, perhaps it's better the second one.
Right, great. And why?
The trend is exponential, and in the first model, it's linear. So we are not taking that in count as much as we take it that in count in the second model.
Okay. And there's one more metric you could use, and that is so whenever you are using any model,
The accuracy.
Yes, accuracy is one of the metrics, but yes, why not? Accuracy is a great metric. Use accuracy, and you'd get to understand which model is better. just use the accuracy function for this and answer your question. And one more element is the amount of data it is understanding. Here, for the log model, it is understand. If you use the adjusted R-square, it is understanding 93% of the data. But when it comes to the linear model, it only understands 75% of the data. So better accuracy metrics and better understanding of the data. So those are the two reasons why we would choose the log model instead of the regular linear trend model. Is that good? Or any questions? Okay, if that is good, well, that is all I had to present for this week. Thanks for being active, thanks for listening, and have a good weekend. If you have any doubts, please stay back. Otherwise, I'll see you in the next week.